Hi there and welcome to another channel video where today I will show everything about the new ZOYI ZT-MD1 smart LCR tweezers. ZOYI is consistently releasing good devices and I'm really curious to check what they sent me, since that these LCR tweezers is being sold on AliExpress at very competitive price. But more on that in the conclusion. The ZT-MD1 was sent for this review directly by ZOYI, free of charge for me, and there was no payment made to produce this video or guidelines set for what I will say. So it will reflect only my opinion on the device. Let me also tell you that they will see the video at the same time you will when it is published on YouTube. That said, ZOYI is collaborating with the channel for some time and I would like to thank the good people at ZOYI for their collaboration, but also you, my viewer, that sponsor the channel by using the affiliate access links on the screen or in the video description whenever you need to access AliExpress or Amazon to do your purchases. You will not pay a cent more, but you will be sponsoring the channel whenever you use these links to access AliExpress or Amazon. So from my part, a heartfelt thank you for your help. Enough chit chat, let's get this party started with the key features. Now it's the time to talk about this video sponsor, PCBWay. I always use PCBWay for creating my boards with a professional factory quality, as you saw in my millivolt voltage reference board. It is very cheap to manufacture your PCBs on PCBWay. You can manufacture 10 PCBs for only $5. How awesome is this? And it is pretty easy also. Just insert here the PCB dimensions and you'll have an instant code. So when you want a PCB, visit PCBWay to get your code, and if it is your first time ordering from PCBWay, you can use our access link for a $5 credit. And don't forget, they also have component assembly service, 3D printing service and much more. So we have here the box where the ZT-MD1 is delivered. It's a white label box, no model, not even a few specs. We know that Zoltec or ZOYI is the manufacturer for a lot of brands, so yeah, they have these white label boxes. Okay, let's see what's inside. Let me open it. Okay, let's take this out. And what do we have inside? Let's start with the user manual. We have this small user manual. It's a folded paper. Okay, we have a few specs in here, and on the back a few more instructions of operation. Let's take it now, and as usual we have the USB Type-C to Type-A cable for charging, probably firmware update also, and we have very well stored in this phone the ZT-MD1. Yeah. Well, for first impressions, this seems well built. It's all plastic, that's true. The feeling that you have while working in the hands, it's okay, it's good. And the blades, they seem to have a little wiggle if you force them. And also these tips doesn't seem to be the more pointy ones that I had here, but I think it will do the job. The pressure, yeah, it's not too much, it's good, and it seems to have some stability, but some wiggle here, it's noted. But if you press one against the other, it doesn't escape, or it doesn't wiggle, so it will probably work well when measuring components on the board. Let's see, I will test it in a few minutes. The screen is okay, it seems big enough, and you have 3 buttons on the top. No buttons in the front, just 3 buttons on the top with mode, frequency, menu, and hold and level. And this is also direction keys. On the back we don't have anything, and on the top we have the USB connector for powering up. So let's see how this works. Let's see now how is the operation of this device, starting up by powering it. Yeah. So in the screen we have several informations. This is in auto mode at this moment. We have also the test voltage in here and the test frequency in blue. So yellow test voltage and test frequency in blue. In this corner we have the battery indicator in green. It doesn't seem to be green. In this angle you can see it. It's green, and the colors are quite bright, quite good. And you can see with this angle that we have a green indicator, and in the middle we have the value that is being measured, and on the bottom we have the resistance series. Also in this corner we have the dissipation. Okay, now it's measuring the capacitance of my hand, it's touching my hand. As I told you before, we have three buttons on the top. The first one is the hold, and it is also the button to change the voltage level, this one in yellow, if you press it for a while. The second button, change the frequency, okay, it's the one in blue, and also activates the menu, and it's also the direction key to the right. And the third one, change the mode, and is able to power on or off the device. So let's see how many modes we have. I think there are 5 modes available. So the first one is resistance. The second one is capacitance. We have inductance and diode testing. And this is continuity. Okay. And we are back to the auto mode. So to change the voltage level, just press for a while in the first button. We have 0.3 volts and 0.6 volts. The frequency is changed by pressing once in this button, the middle button. We have 10K and 100 and 1K. Okay, so those are the 3 values available. Also, if you press in the middle button for a while, okay, a long press, you will have the menu. In the menu, you just use the direction keys to navigate and the mode to select. For example, if we want to change language, just press it and you are able to select. In terms of language, we have English and Chinese. In terms of direction, you can be right-handed or left-handed. We have also the volume. In terms of volume, I will take a bit to off, yeah, like this. And we have also the backlight. In terms of backlight, I will also diminish a bit because it gives a better reading while recording. Okay, that's good. And what else we have? We have the timer. So the timer will power this off after 15, 20, 25, 30. Okay. All the way up to 90, 120 minutes, and the minimum is, okay, now I have to go all the way back. Yeah, you can disable this function with the off and the minimum of 5 minutes. I will leave it at 15. We have also the calibration menu in here, and the restore, and finally the about menu with the version. Right now I have the 1.8 firmware. And that's it in terms of menu. As you can see, pretty easy to use, no fancy things. It's very direct to the point. Okay, let's go back to the main menu, and right now it's much better the way you can see the colors. You can see that they are very bright, and it's very easy to see what is on the screen. And for operation, that's it. Let's move on. Now I will test the resistance measurement. For that, I prefer to use the manual mode instead of the auto for the testing. So yeah, I will set up this for resistance. Well, in terms of the values and the calibration, I didn't change anything. It is with the calibration that came from the factory. I will start by testing with 0.6 volts and 100 Hertz in terms of frequency. Let's start with the first value, that is 10 ohms. Okay. Let me see. I have to do this in a way you can see the values. So 9.9899, it was almost spot on at the 10, but it seems that it moved. So 9.99, let's say it. And the second value is 100.03. Okay, let's see it. 99.9.8, something around that. And now the third value is 1.0003K. Okay, let's see what we have. It's always a bit low, but not far. It's almost spot on there. Yeah, okay, 1. And then we have 9.995K, almost 10K. Let's see what we have in here. Okay, 9.993, very near, almost spot on. Okay. And also the last one is 100.06K. Let's see what we have. 1.01, oops, it's changing. Okay, it's almost there also. Okay, let's now change the frequency to 1K, sorry, and try again. $9.995 for a 10 value, and let's see with 10K if it is more accurate, more near the value. Okay, not really. Let's see the second one, 100K, 100 ohms. No, and this is 1K, almost there also, and with 9.995, it's a little far from the value, and 100.06 also a little more far from the value. Okay, let's now change to 3 volts, 0.3 volts, and see if it impacts in anything. 9.991, no, the value is basically the same. Again, also the same. 1K, also the same value, so it doesn't interfere. Okay, 9.995, this one. Okay, around the same, and 100.06. Yeah, also oscillating a bit, but more or less the same. So now I will test the capacitance. I will use the same board that now has some values for capacitance. Already in here, let me just take this to 100 Hertz. I will test the 3 frequencies for each value, so it will take a bit more, but let's see how we get. 102 picofarads, almost there at 100 Hertz. Let's see at 1K. Okay, almost spot on, 106 picofarads, and 10K. It is really, really near. Okay, the second value is 1.02 nanofarads. Let's start with 100 Hertz. Okay, 104. This is very near the values I got in my last tests done with this board for the ET14S from Tooltop, I think. So 104 nanofarads at 1K, and 10K, also the value, 103.4 nanofarads. So it's near the value sign on the board. Let's go now to 10.4 nanofarads. Okay. 10.95, something like that. 1K, 10.56, and 10K, it will give you 10.46. 10.46, it's what we have here signed in the board. So I will say that at 10K this is spot on. Okay, again 100 for the 98.7. Okay, a bit over. 1K. Okay, it's near the value, and finally 10K. So a 10K, it's when it's measured best. 99.55. That's really near the 98.7. This one, it's 929, but in reality it should be around 880 nanofarads. It's the value I get in all the devices I test. So let's start with this one. Okay, 909 nanofarads, 901. Okay, let's see with 1K what we get. 887, so we are getting near the value I told you. And with 10K, it is 846. So this is giving a little bit different values that I usually have. So let's move on to the last one. It's 10 microfarads. Let's start with 100 Hertz. Okay. Almost spot on. 1K. So 1K is a bit below. And 10K it's 8.2. Okay, that's it in terms of testing capacitance. For testing the inductance, I will use this board with values from 1 to 1000 microhenries. I'm using 0.6 volts and 1K for measuring this. Let's start with 1 microhenry. Okay, spot on, very nice. The second one is 1.2, 1.3, okay, a bit over. Let's see, this one should be 5.6. No, not this one, this is 4.7. The next one is 5.6, 5.7. 6.8. Okay, this last one is 33. 3293, very nice, very near. We have also 39 in this second row. Okay, around here should be 180, very near. And the last one should be 1000 microhenries, 1021. Okay, in terms of inductance, that's it. So now I will test some diodes. I will start with this 1N5817, and to verify I have also here my ZOYI 703S, a very reliable multimeter. And for testing the 1N5817, 18 and 19, I will use the 0.3 volts 1K, and we have a reading of 0.22 volts. Okay, let's confirm it with the multimeter. Okay, I have it down, and yeah, 02.19, pretty near. Okay, let's try now the 1N5819. Okay, and for this one the multimeter reads 0.226, very nice. Let's see what we have with this MD1, 0.22 also. So pretty in line. We have one less digit in this one. And for testing the other 1N4000 series, I will use the 0.6 volts. And for that, for example, the 1N4001 will report 0.51 volts. Let's see what we have with the multimeter. 0.83. So we have a little difference here. Okay, let's try 1N4003. And for this one, we will have a reading of 0.600 volts. Okay, let's check with this MD1. Again, 0.51. One thing that you don't have to worry is the direction of the diodes. He measures in both ways. And this is not the diode that is broken. It's really like that. Okay. If you try it here with the multimeter, it reads from one side, but from the other side, it will not read. Okay. So this this one had also a little difference. And finally, let's do a 4005, 1N4005, also 0.600 volts. Let's see what we got in here, or we get in here. Also 0.51. Let me try to change the frequency. No change, yeah, almost no change in there. Okay. Yeah, all the same. And if you try with 0.3 volts, let's see what we have. It is not able to read it. Okay. Either side. Okay. Okay, so in terms of diodes, that's it. Continuity test. We can check always the resistance of the contact just by closing the tweezers like this. It should be around 0. Yeah, yeah. And let's go to continuity. Yeah, this one. So, okay, let's see how fast this will answer. It's amazing fast. It's almost instant. Even the screen is really fast to update. I'm really curious to see what is the MCU or the processor or whatever that powers this device, because this is really fast to update and has a very nice sound. Yeah, no problem about it. Okay, this is a pass. Let's continue. I connected my ZT-MD1 to the oscilloscope, and we can already see that we have a perfect sine wave output at 100 Hertz, like we have it here. And in terms of frequency, it is confirmed. It is outputting 100 Hertz without any issue. And we can also see that 0.6 volts is detected here as a AC RMS with a VPP of 1.7 and upper line at 650 more or less, and the lower 689. Okay, let's move the frequency to 1 kilohertz. We immediately saw the change on the screen. The voltage also adapt a little bit, not much. But yeah, everything else is correct. We have here the frequency at 1 kilohertz and 10 kilohertz also check, and it detected a little voltage drop here on the ACRMS, but we still have the V upper and the V lower at over 600 millivolts, so that's okay. Let's now try to change the voltage, the amplitudes. As you can see, it changed the amplitudes of the signal. Right now we have a VPP of 860 millivolts with a V upper of 334 and a V lower of 350, more or less. Right now we are at 10 kilohertz, 100 and 1K. Everything seems fine, nothing to point out. So I have my Arduino Leonardo here. I normally use this board for these tests and temperature and stuff like that. As you can see, it has very small components in here. Let's start with this one. I think this is, for the color, I think this is a capacitor. Let's see what we have. Yeah, 9.8 microfarads, very nice. And this should be also a capacitor, 97.6 nanofarads. We have there the resistance series and also the dissipation. We should have in here, yeah, this should be a resistor, I think. Okay, 1.5 mega ohm. And this other component is 61 milli 75. Yeah, this varies a little. 2.6 milliohm. Okay, very nice. And this is what? Capacitor? Yeah, 7.3, I think. And we have some more in here. Let's see what we have. What is this one? Okay, is a resistor, 1 mega ohm, and should be a capacitor, I think, this little one. No, resistor also. Okay. This one is not reading. Okay. 0.7 milliohms. And yeah, that's it basically. You can, let me see if I can check these diodes here. Okay, it will read as resistor 1.19. This is in auto mode. You can see it detects fairly fast capacitance right now, 85 nanofarads. Yeah. Okay, one more just to end. So let me see. 9.9. So this is 10 microfarads also. Okay, that's it. Let's move on. And now is teardown time. Well, this is very easy to open, quite uncommon, and we seem to have a very nice board in here. Let me see the battery. We have a 500 milliamps hour battery, 3.7 volts. Yeah, I will have to put this under the microscope to see better, but yeah, we have a few components in here. Something really cool and unusual also is this, the arms are PCBs connected to the main PCB. Yeah, that is a first. Okay, and yeah, let me see what we have under this. Okay, we have an IC. I will have to put this under the microscope because like this I cannot see what is in here. I have the ZT-MD1 under the microscope already. It seems a very well built motherboard very optimized. And yeah, but for what I could see previously, I only found the specs for 2 of the ICs, and being this one the first, let me zoom in a bit more. Okay, maybe like this we can see better what's there. So let me get this to the side so we can see the PDF. And this is a AT32F403A. It's an ARM-based 32-bit Cortex M4 MCU plus FPU, and is able to reach 240 MHz of maximum frequency. And this model, that is the ACGU7, has 1 mega of flash memory. So pretty good, really, really good. And the other one that I found the specific was this RS8552. And this one is a zero drift rail-to-rail I/O CMOS operational amplifier. I suppose the next to it should be also something like that, but I was not able to find the datasheets for those two. Okay, so let me take the zoom out. Yeah, like this. Okay, those 2 ICs that I mentioned are the 2 that we can identify. I even tried to find out what this in here is, but no luck with it also. Yeah, basically that's it. You can take a look in the board. We have the USB connector here, the connectors for the battery. Probably this one is a charging controller, 57B0. If you know what it is, let me know in the comments. But yeah, that's it, basically. Wrap-up time, and as always, starting with the price, it is being sold on AliExpress ZOYI official store at roughly 23 euros or around $26, and considering the other devices of the competition, it is a really nice price for what you get. In terms of accuracy, it is accurate enough. We probably can even get better results with some calibration. But I do my tests with the factory calibration to be equal to all the devices I test. In terms of construction, it's all plastic, ABS to be more precise, and the quality is good enough for the job. The use of PCB for the tweezer arms is very ingenious and it works very well. The information on the screen is presented in a very clear form and it is really easy to read. It took all day to record this video, and during the day the ZT-MD1 was mostly on and being used on some test or function demonstration. By that time the battery don't even went down a block, so I'm not sure how much time you can work with it. The ZOYI claims that it can work for 12 straight hours, but I can say that for me it will work at least 2-3 more days without any problem. The device that I received didn't come with it, but it seems that you can order also extra bent tips that in some cases might be handy. Everything considered, it is a nice and budget-friendly tool to have on your workbench. For me, one of the most common uses I use mine is to check components on those rolls or strips of components that sometimes don't have marks visible on the outside, obviously, and also the components on PCBs, but for checking inside those strips of components, it works really well. If you are searching for a budget and accurate smart LCR tweezers like the ZT-MD1, and this device is exactly what you need, please don't forget that if you enjoy the channel videos and all the work I put in each one, you can sponsor the channel just by using the affiliate access links on the screen or in the video description whenever you need to access AliExpress or Amazon to do your purchases. You will not pay a cent more, but just by using these links, you will be helping me to continue producing these videos. From my part, please accept my sincere and heartfelt thank you. And you will also not have to pay a cent more to slap that like button and tickle the YouTube algorithm to help the channel grow. And if you are new here or just didn't subscribe yet, let me tell you that by doing so, it will help you to be on the loop with all new equipment that hits the market and every week I receive and review here in the channel. That's it for today. Thank you for your time and company. I hope to see you in my next video. Until then, take care.